Okay, so I know this is always a funny, like crazy type of situation when we're doing or using the normal distribution to approximate binomial cases. So there's extra steps involved in that when you're doing that. So let's see what we have here. Estimates for children with ADHD vary by age, state, and other considerations. For 12 to 17-year-olds, it is approximately 13%. If 93 children within that age range are checked into a county or checked in a county, what is the probability that 4 or fewer have ADHD? So P in this case, which is the probability of success in this case, is 0.13. We know that Q is the complement of that, and I always find Q when I have P. So I'm always going to do that. 1 minus 0.13, which is 0.87. And I'm always looking for my sample size. 93 children are selected, so my sample size is 93. Now, they don't always ask you to test to make sure that you can use normal distribution approximations, but in Newton, they'll describe that portion of it. So technically, we should always be checking to make sure that these two facts NP is greater than or equal to 5 and NQ is greater than or equal to 5. These two have to be true in order for us to do these methods. So the first check is always to go and find N, which is 93, times P, which is 0.13, and determine what that value is. And if it's greater than or equal to 5, that's good. And N, I'm going to bring this over here, N, which is 93 times Q, which in this case is 0.87, and find that value. That also has to be greater than or equal to 5. So let's find those values on the calculator. So we get, when we do 93 times 0.13, we get 12.09, which is definitely bigger than 5. So this one's good. And when we do 93 times 0.87, we get 80.91, which is definitely bigger than 5. So our requirements are met to be able to use normal distributions to approximate your binomial case, which is this. So that's the first portion. Now, there's no mean or standard deviation. So when I'm doing normal distribution, you know that you have that lovely bell-shaped curve, but you need to know what the mean is and what the standard deviation is. So whenever you're finding the mean of a binomial situation, it's N times P. And whenever you're finding the standard deviation of a binomial situation, it's always N times P times Q under the square root. So we know that N times P was 93 times 0.13. And we know, we don't know this, we'll find it, but we want the square root of N, which is 93, times P, which is 0.13, times Q, which is 0.87. So let's see what those values are, because we need those to do our calculations. Okay, so 93 times 0.13, 12.09, and square root of 93 times 0.13 times 0.87, which is approximately, so I'm going to take a bunch of these, 3.243, I'm going to take a lot, 3.24319. Okay, so maybe I'll take one more. So typically, when you're doing this, you want to take at least 5 to 6 digits to the right of the decimal place because of the fact that you're going to use this to calculate something else. You don't want to round too much here. So I like 6 digits to the right of the decimal when I find the standard deviation here, because again, we're going to use it when we do our normal CDF, which is our next step because we're asked for probability. Now, when I'm doing binomial, here's the thing. Okay, when I'm doing binomial with a normal distribution approximation, I like to draw my curve. The center of my curve is my mean, which is 12.09. But our value that we're asked about is 4. So maybe I'll put that in red. Okay, 4 is going to be over here. Figure not drawn to scale. But whenever we're doing binomial approximations, we always have to represent that value with 0.5 below it, 3.5, and 0.5 above it, 4.5. So technically, these two numbers are basically representing 4. Now, this is very important when we're trying to determine the area, because it's very important whether I'm including 4, not including 4. Do I start at 3.5? Do I start at 4.5? This is the part that can get funky. Now, if I want the probability that 4 or fewer, that means less than 4, including 4, right? Less than 4, including 4. And when I talk about less than in terms of probability, I'm talking about an area to the left. So I'm looking at an area to the left. Now, I know that I'm going to find the area to the left, but do I use 3.5 and find the area to the left of that? Or do I use the 4.5 and use the area to the left of that? I'm including 4, which means when I do my area, I have to include 4 in it. So I'm going to do the area to the left of 4.5. So what is the probability? Find the area basically to the left of 4.5 for the binomial case. And when I'm looking for area, I always go normal CDF. Let's check our calculator. So we want second bars down to normal CDF, which is number 2. My lower bound is going to be like negative infinity. So we use this negative 1e99. My upper is 4.5. My mean we found to be 12.09. My standard deviation we found to be this value, 3.2431. And we should probably use more values there, but my area, which is my probability, is approximately, I'll put that in black, approximately 0.0096. And typically about 4 digits to the right for probability.